Hey guys, Mike here from ArnoldTutoring.com, and here we're going to draw out two very important tables that show the relationship between our derivative and our function, as well as our second derivative and our function. Again, these are really important when we go to graph different equations, because we don't necessarily know what a bunch of equations look like off the bat when they're not just simple quadratics or lines that we do know what they look like. So we have to use our derivative and our second derivative and the relationship that those hold with the function to start drawing an accurate picture. So let's talk about what we've already done in a separate video, which is the first derivative. Remember, the first derivative is the slope of the tangent to a curve. So if we find out that the first derivative is negative, what does that tell us about our function? Well, a negative slope means it's going down and to the right, so we call that, on the actual function, it's going to be decreasing. Going down and to the right. Decreasing. A picture that's just going to look, it's going to go something like that, right? Down and to the right. Okay, perfect. What about if our first derivative is 0? If the first derivative is 0, it's not guaranteed, but we know that the function itself is flat, and this almost always results in a max or min. It definitely works the other way, where if we find a max or min on the function, then we know the first derivative is 0. If we find the first derivative being 0, it's most likely it either flattens out at that point. So just to give a quick example of that, because we haven't really talked about that, it does happen sometimes. If you get a function that looks like this, you can see that the first derivative and the function is actually flat there at that point, but it's not an actual max or min, right? It doesn't, because it's increasing the whole way. So that's technically not a max or min, even though the first derivative is 0. But for most of the time, if you find the first derivative being 0, that's going to result in a maximum or minimum. What does that look like? Well, that just looks like the function flattens out like that, so that'll be the slope of the tangent. And lastly, I'm just going to erase this so that we have some room. Lastly, if our first derivative is positive, we find the first derivative to be positive over a particular interval, that means our function is going up and to the right, which we call increasing. And it's going like that. Great, so that can tell us sort of the direction with which our function is going over a particular interval of x values based on the derivative. Now let's talk about the second derivative, and we're going to look at, I'll do this in a different color, we're going to look at the exact same three scenarios. So negative second derivative, a 0 second derivative, and a positive second derivative. Now the second derivative is like the derivative for the first derivative. If that doesn't sound confusing, I don't know what does. So what does that mean? It means it's the rate of change of the derivative. So we basically say, okay, not only is it going up and to the right, but is it going up and to the right at a quicker pace? So is it going more and more steep, or is it starting to flatten out? So what that tells us, if it's negative, that basically means like the derivative is slowing down, or you can think of the function is actually slowing down. So if it's increasing at a slower rate, and we call this concave down. So the picture is, it looks like that. So there could be a section of the graph that sort of has that downward motion. Let me give you a quick, I'll draw another quick example up here. Let's say we have a function like this. Kind of similar to the one I just drew. You can see on this portion, it's kind of got that upside down U, and then right around here, it changes to having a right side up U. Well, this section is concave down, and this section is concave up, and we'll talk about that. How about 0? That's called a point of inflection. When the second derivative is 0, we call this a point of inflection. And all it means is exactly the same as the first derivative. When we said in the first derivative, if we go from positive to negative, that means there's a local max there. Same thing here, if we go to positive or negative to positive, there's a point of inflection. That's happening in this picture right there at that point because it's changing concavity. It's changing from concave down to concave up. As far as the picture, again, it's going to be, there's no real picture here, right? It's either down to up or something like up to down. And lastly, positive. If the second derivative is positive, that means it's increasing its rate of change. So we call that concave up. Right? So it's getting more and more steep, or or more and more steep downwards. It doesn't really matter which way. And so we think of that as the right side up u. So you can see the parallels between what the first derivative says and what the second derivative says about our function. These are the two tables we really need to know as we get into curve sketching. Hopefully you found this helpful. You can always send us more questions, info@arnoldtutoring.com. Thanks.